All right, greetings everyone. Welcome to the second part of the video for section 5.1, continuing on with our first set of new material. Okay, so in the previous video we learned about the distance formula, and it turns out that that is the basis upon which we can form the general equation for a circle. So notice first of all that if we think of a circle in terms of stuff that we learned in PreCalc 1 or that maybe you learned in wherever you took PreCalc 1, notice that a circle does not fit the description of what it means to be a function. And the most notable thing there is that it does not pass the vertical line test. So notice I can draw vertical lines in several different places so that it will intersect the circle in more than one spot. However, even though it's true that circles are not functions, they are still important shapes that we need to be able to consider, so we need to be able to write the equation of a circle. Now I'm going to write down what the general equation is. So it is given by x minus h quantity squared plus y minus k quantity squared equals the length of the radius of the circle squared. And notice first of all, those values h and k, those come from the coordinates of the center of the circle here. And then r here, as I mentioned, that's the length of the radius of the circle. And as a reminder, a radius is the distance from the center of the circle to any point on the outside of the circle. So like this, that part I just highlighted. Now it turns out that the general equation for a circle comes from the distance formula, and I'm not going to go all the way through that. But you could probably notice from looking at the diagram over here that if I were to find the distance between the center of the circle, hk, and any point on the outside of the circle, which we'll call xy there, then if you think about how the distance formula works, you hopefully would agree that we should probably get something like x minus h squared plus y minus k squared. That would all be under a square root, and that distance would be equal to r, the length of the radius. But then if we square both sides, we would end up with this formula we have here. Okay, so that's where it comes from. So let's look at using that on a couple of examples. So the first one we have here, we're asked to find the equation for a circle whose center is the point 2, -3, and for which the radius has a length of 5. So notice because we're given the coordinates of the center there, we know those will represent the values of h, comma, k, and that's always the order that it goes in for the center of the circle. So the first part of the coordinate is h, the second part is k, and then again we have that value for the radius there is 5. So if I write out our general formula for the equation of a circle, x minus h squared plus y minus k squared equals r squared. Well, notice we can just fill in the information we have. So we have the value for h, we have the value for k, and we have the value for r. So we'll go ahead and plug those in. So we'll have x minus the value for h, which is 2 squared, plus y minus the value for k, which notice is -3, so I'm going to put that in parentheses, squared, equals, and then our value for r, which is 5 squared. And at this point, we're actually pretty much done writing the equation. If we want to, we could simplify a couple of things here. So notice, first of all, we have this minus here and the y minus -3. So we can make that a plus. We also have the 5 being squared. So we could simplify that if we wanted to. Now it's not necessary, but it's kind of a nicer form if we write this as x minus 2 squared plus, again, the minus here makes y plus 3 squared, and then equals 25. And there we are. That is the equation for this particular circle. Now, a couple of things I want you to notice about this. First of all, we just left x and y as is. Okay, and that's pretty typical whenever you're writing the equation of something. You should have variables left. So that's why we did not plug in anything for x and y or solve for x and y. And then also we all notice we didn't deal with the squareds here and squaring out these terms x minus 2 and y plus 3. Again, we can just leave these exactly as they are. Oops. Okay, let's look at the second one here. So we're asked to write an equation for the circle given in the graph to the right. So we have a circle here. We need to write the equation now. So recall, again, we'll use this x minus h squared plus y minus k squared equal to r squared. And again, we need to identify the values for h, k, and r. So to find the values for h and k, we need to find the coordinates of the center of the circle, which looks to be right there. And those coordinates look to be -2, 1. And then we also need to find the length of the radius. Now recall again, the radius is the distance from the center to any point on the outside of the circle. And in this case, we can make our job easy by picking a length or a radius here that's easy to find the distance of. So for example, that one right there. When we do that, it looks like we get r equals 2. So if we now plug in this information, the values for this coordinates of the center of the circle, as well as the radius. Remember, the coordinates for the center are h, k. We can plug that into our formula over here. So we'll have x minus -2 squared plus y minus 1 squared equals 2 squared. And then just like in the last one, we can do a bit of simplifying to make this x, the minus minus here would make a plus 2 squared plus y minus 1 squared. And then the 2 squared there gives us 4. Okay, and that would be our equation there. Great. One more example. So here we're given the equation x minus 4 squared plus y plus 1 squared equals 9. We're asked to find the, let's should say the coordinates of the center of the circle, the diameter of the circle, and then they want us to graph it on the provided coordinate plane. And again, this might sound repetitive, but it's sometimes repetitive is good. We're using this form x minus h squared plus y minus k squared equals r squared. We can compare this to the equation we've been given. So the x minus 4 squared plus y plus 1 squared equals 9. We can start by finding the coordinates of our center, which we know are going to be given by the values h and k, which notice, if we compare, again, the given equation to our general form, well, it looks like for this first part, we can fairly straightforwardly identify that h, the value for h is 4. But what about k? Because notice here we have y minus k, but this is a y plus 1. Well, if you think back to the previous examples we did, this y plus 1 can be written as y minus -1, right? Negative negative makes a positive, so y plus 1 is the same as y minus 1. And notice now that is in the form y minus k. So we see the value for k there would be -1. All right, so we have the coordinates of the center of our circle. And the next thing we're asked to find is the diameter, the length of the diameter of the circle. Now notice first of all, from what we're given, we see that the value for r squared is equal to 9, because that's in the place of r squared, which if we solve that by taking a square root on both sides, we get r equals 3. so that gives us the length of the radius to be 3, but we're not looking for the length of the radius, we're looking for the length of the diameter, which, if you recall, the length of the diameter of a circle is double what the length of the radius is. So in this case, it would be 6, and we'll say units here since we weren't given any units to work with. All right, we've got the length, or the coordinates of the center. We've got the length of the diameter. We also have the length of the radius, which I'll just circle, because that will help us now find or draw a graph of the circle. So to draw the graph, start by marking the center of the circle, which is at the point 4, -1 here. And then we know our radius is 3, so we can kind of go 3 units in each direction from there. I'm kind of going to do something like this. And then I'll do my best to kind of connect the dots here in a circular form. And there, now we have our circle. Okay. All right, that's it for now. Thank you for watching.